Assalamu alaikum students. How are you all? Hope so you are enjoying your good health. First of all, congratulations for being entering in this holy month of Ramadan. May Allah Pak accept all of our good deeds and ibadats. Students, today we are going to start from question number 7 as we have done all question from 1 to 6 in the previous lecture. Students, as in the exercise 1.1 we have discussed about the equal matrices. This question is same because there is equality between the two matrices, so it's mean these two matrices are equal. This matrix, after solving, it equals to this matrix. So first of all we will solve this side, and when we will get a single matrix, then we will compare the corresponding entries like in the exercise 1.1. Okay students, first of all we are going to solve this side. As you can see, this is 2 multiplying with this matrix plus then 3 is multiplying with this matrix. So we will multiply this 2 with each and every entry of this matrix. So it will be equals to, we will not put sign of equality because there is already equality. So 2 will be multiplied by 2, answer will be 4. 2 into 4 is 8. 2 into minus 3 is minus 6, and 2 into a is 2a. Plus, now we have to multiply this 3 with each and every entry. 3 into 1 is 3, 3 into b is 3b, 3 into 8 is 24, minus 12. 3 into minus 4 is minus 12, equals to 7 and 18, 8, 10 and 1. Okay, now these two matrices are adding. So we will add their corresponding entries. 4 plus 3. 4 will be added in 3 because of the corresponding entry. Similarly, 8 will be added with 3b. 8 plus 3b. Next, minus 6 plus 24. 2a, as plus minus is minus, so minus 12 equals to the same matrix 7, 18, 10 and 1. Okay, now we will solve this. 4 plus 3 equals to 7. 24 minus 16, this is minus, this is plus, so plus minus minus, and sign will be of greater value. 24 minus 6 is 18. Next, students, this is 8 plus 3b. We cannot write it like 11b. We will not add them. Why? Because these are unlike terms. This is a constant value 8 and this value is with variable that is b. So we cannot add them. These are not like terms. So it will remain as it is, 8 plus 3b. Similarly, 2a minus 12 will remain as it is. And this matrix is equals to 7, 10, 18 and 1. Now we are having the single matrix which is equals to this matrix. As there is sign of equality between these two matrices, so we can say their corresponding entries are same. You can see 7 is equals to 7, 18 is equals to 18. These are the variables. So 8 plus 3b will be equals to 10. From here we will find the value of b. And this is 2a minus 12, it will be equals to 1. So from here we will get the value of a, like 8 plus 3b will be equals to 10. No need to write 7 is equals to 7, 18 is equals to 18. We can see they are equal, just we will solve this side because of the variable. 8 plus 3b equals to 10, and we can write 2a minus 12 equals to 1. So this 3b will be equals to 10. This is plus 8. On the other side it will be minus 8. 3b equals to 10 minus 8, 2. And b will be equals to 2 by 3. Similarly, this is 2a minus 12. So 2a will be equals to 1 plus 12. 2a will be equals to 13. And a will be equals to 13 by 2. These are the values for a and b. Okay students, before starting the next question, we are going to discuss 2 more types of a matrix. Number one type is the symmetric matrix. What is the symmetric matrix? For example, we are having a matrix A, and if I am taking its transpose, and after taking the transpose, the matrix is equals to itself, then it is said to be a symmetric matrix. Means after taking the transpose, if you are getting the matrix itself, then it will be called as the symmetric matrix. Let's suppose I am having the matrix M, and these are the entries 1, 2, 3, 2, minus 1, 4, and 3, 4, 0. Okay, now I am taking its transpose. I have to write a small t on the name of the matrix, which indicates that we have taken its transpose. Okay, now I will write the row in the form of column, or you can write column in the form of row. I am taking the rows. I am going to change all the rows. First row is 1, 2, 3. I have written it in the form of column. Second row is 2 minus 1, 4. This is in the form of column. And last one is 3, 4, 0. Now you can see this matrix is equals to the matrix M. We can write is equals to M. So the condition is satisfied, that is M transpose is equals to M, the matrix itself. So if this condition is satisfied, we can say that the matrix M is a symmetric matrix. Now students, the next type is skew symmetric matrix. In skew symmetric matrix, just the difference is there if you are taking the negative of a matrix and it is equals to negative of itself. What was it in the symmetric matrix? No negative sign was there. Matrix transpose of a matrix was equals to itself. Now in skew symmetric, the transpose of a matrix is equals to negative of itself. If this condition is satisfied, we can say skew symmetric matrix is there. Suppose we are having the matrix A. You can see these are the entries of the matrix A, and for the skew symmetric we are having this condition. Transpose of that matrix should be equal to negative of itself. So this is left hand side and this is right hand side. I have solved left hand side first. A transpose means I have taken transpose, like I have written the row in the form of column, this row in the form of column, this row in the form of column, right? This is left hand side. Now the right hand side is negative of A, and you know the negative of a matrix, you will change the sign of each and every entry. So I have changed all the signs. This 0 will remain 0 because we will not put any sign with 0. Then all positive numbers are negative now, negative are positive now. This was positive and it is negative now. Now this is right hand side. You can say the matrix A is skew symmetric. Why? Because left hand side is equals to right hand side. Clear? Means we have taken A transpose and then it's negative, both are equal. Then the condition for the skew symmetric is satisfied. Now we can say that this matrix A is a skew symmetric. Now the next question is question number 8. We are given two matrices A and B and we have to solve this. We have to verify this side is equals to this side. Students, we can take both sides together or we can solve it by left hand side and right hand side. Now I am going to solve side by side. Like this is A plus B whole transpose. In this, just we have to put the values of the given matrices. Instead of A, I am going to write this matrix, and instead of B, I am going to write this matrix B. So the condition will be matrix A 1 2 0 1 plus matrix B 1 1 2 0 and then whole transpose, right? Just we have to put the values, and in this side we are having A transpose plus B transpose. Means first we have to take the transpose, then we will add the matrices. But here first of all we have to add the matrices, then we will take their transpose. So matrix A is 1 2 0 1 1 1 2 and 0. Now we will add these two, and you know how to add the matrices. Their order should be same. Their order is same. You can see this is 2 by 2. This is also 2 by 2. We are going to add their corresponding entries as by the law of addition. 1 plus 1, 2 plus 1, 0 plus 2, 1 plus 0. So it will be equals to 2, 3, 2 and 1 whole transpose. Now we are going to take its transpose. We will change the row into column. Second row 2 and 1. It's mean I am not writing T here. It's mean I have taken transpose. Now in this side, first of all, we have to take the transpose. This row will be written as column. Second row again will be written as column. We have taken transpose. Now we will not write T. Plus, we have to take the transpose 1, 1, 2, 0. Okay. Again, I have not written T. It's mean I have taken transpose. Now we will add the corresponding entries. 1 plus 1. 0 plus 2, 2 plus 1, 1 plus 0. And you can see this is 1 plus 1, 2, 0 plus 2, 2, 2 plus 1, 3 and 1 plus 0 is 1. So now you can see both sides are equal. And we have verified that A plus B whole transpose is equals to A transpose plus B transpose. Okay students, now this is your part number 3. Part number 2, you can do it yourself, just negative sign is there. In part number 1, we have added the matrices, and in part number 2, you have to subtract the matrices. Now the part number 3 is there, A plus A transpose is symmetric. Students, we have discussed this in the previous lecture. What are the symmetric matrix? For example, any matrix is there, suppose A. So if its transpose is equal to the matrix itself, then it is called as the symmetric matrix. Now we have to prove this A plus A transpose is symmetric. So A plus A transpose, the condition is there. Whenever you have to show the matrix is symmetric, its transpose should be equal to itself. Means this is the condition. You have to take the transpose of that matrix and it should be equal to the matrix itself. So now we have to prove A plus A transpose is symmetric. We have to write A plus A transpose equal to itself, right? A plus A transpose whole transpose is equal to itself. This is the condition of symmetric matrix. Now we have written the condition, just we have to solve it. Now I will just put the values of the matrix A 1 2 0 1 plus A transpose. You can directly write its transpose or you can do it in the next step. I am taking it directly. This is A, so I am going to write its transpose, means the row should be written in the column or column should be written in the row, and then whole transpose. Is it clear? On the other side it will be A, what is A? 1 2 0 and 1 plus A transpose. What is A transpose? Yes, 1 2 0 and 1. Clear? Okay, now we have to add these two, then we will take transpose. And how you will add? Obviously you have to add their corresponding entries. 2 plus 0, 0 plus 2 and 1 plus 1 whole transpose. And on this side again you have to add the corresponding entries. 0 plus 2, 1 plus 1. Okay, now we will add them. This will be 2 2 2 2 whole transpose is equals to 2 2 2 and 2. On this side we have to take its transpose, so we will write this row into column, second row into column. So this is the same, and you can see both sides are equal. So we have proved that the matrix which we have to show, this is a symmetric matrix, its transpose is equal to itself. I am telling you again, whenever you have to show some matrix is symmetric, then you will take the transpose of that matrix. It should be equals to the matrix itself. This is the condition. Now just we have to put the values and then it will be proved. Here is the next part, that is A minus A transpose is skew symmetric. So first, the condition of the matrix to be skew symmetric is that if we take the transpose of any matrix and it is equals to the matrix itself, then the matrix is said to be skew symmetric. Like suppose I am having the matrix A and I have to take its transpose. It should be equals to the negative of A. Then we can say the matrix A is a skew symmetric matrix. Now according to the question, we have to show that A minus A transpose is skew symmetric. So what will be the condition? Means we have to take the transpose of a matrix and it should be negative of itself, right? This will be the condition. You have to take the transpose of that matrix and it should be equals to the negative of that matrix. And what is the matrix? Obviously in the question we have to show A minus A transpose is skew symmetric. So we will write A minus A transpose in this bracket. A minus A transpose. Now the same condition is there. Whenever you have to show a matrix is skew symmetric, you will take its transpose. It should be equals to the negative of that matrix. And now we have to show A minus A transpose is skew symmetric. So its transpose is equals to negative of itself. Now we will just prove this. Just I am going to put the values like this. What is the value of A? Value of A 1, 2, 0, 1 minus its transpose. Its transpose will be, this is row, I have to write it in the form of column. Next again row will be written in column. Is equals to minus A. Instead of A, I have to put the value of matrix A. And minus A transpose means now we will write the transpose of matrix A. This is matrix A, so I have to take its transpose. Okay, now in this side, firstly we have to subtract them, then we will take their transpose. Like 1 minus 1 for the subtraction, you know, for the subtraction we have to subtract the corresponding entries. 1 minus 1, 2 minus 0, 0 minus 2 and 1 minus 1. Then its transpose is equals to minus, and first we have to take, will do the subtraction. 1 minus 1, 2 minus 0, 0 minus 2, 1 minus 1. Okay, it will be now 0, 2, minus 2 and 0. Its transpose, and now we have to take its transpose. It will be 0, 2, minus 2 and 0 is equals to minus as it is, and this will be 0, 2, minus 2 and 0. Now we will multiply this minus with each and every entry. So it will become 0, you know, we will not put any sign with 0. It will remain 0. This 2 will become minus 2. This will become plus 2. And this is 0. You can see both sides are same. It's mean we have shown that A minus A transpose is skew symmetric. Students, with the same pattern you can do the rest of the parts. In the next parts you are having B minus B transpose is skew symmetric. So you will use the matrix B now, and for B plus B transpose is symmetric, again you have to use the matrix B. You can do it yourself. Okay students, this was the last question of your exercise 1.3. You have to do the practice of the given questions and you will do the remaining parts of question number 8 as well. Okay, Allah Hafiz.